how wireless charging works and what advantages wireless chargers offer. Electronic devices are increasingly becoming indispensable accessories in people's lives, as they have a wide range of functions that are used daily. Therefore, it is essential that their energy charge is maintained. In response to this, a more practical and eco-friendly solution was sought: wireless chargers. Now then, what exactly is wireless charging and how do wireless chargers work? We'll tell you about the advantages of this type of chargers. What is wireless charging? Basically, it's the transfer of energy from one device to another through waves. The purpose is to replenish the charge of electronic devices so that they continue to function. In contrast, others define it as a very simple and innovative system that produces an energy flow through induction. Only a device that generates the electromagnetic field and another that receives the energy is needed. Although in reality it is a very complex internal process due to the development, connection, and transmission of electricity, which for the human eye only involves connecting the generator and transferring energy to the device. Generally, electronic devices come with a default traditional connection that includes a plug and a USB cable that connects to the device. This system provides a constant and rapid flow of energy. However, it decreases the lifespan of the ports. On the other hand, wireless charging supplies energy without the need for a connector. This feature makes it one of the original corporate gifts when promoting an event, a product, or a service. How does a wireless charger work? Wireless chargers have a small base or platform that supplies current to mobile devices. This process includes magnetic induction in order to recharge the batteries. However, depending on the model and its technology, it is often not necessary for the device to be attached to the generator. Some people think that wireless chargers do not have any type of cable. However, the base requires a conductor or cord that is powered from an electrical outlet to perform its function. What is true, however, is that it does not require a USB cable to connect the phone to the platform. The most important work is done by the induction coils of both devices, since one receives the alternating current and sends it to the other device. However, how do the two devices connect without a USB cable? Let's see in detail the secret behind this. The coil of the base, considered transmitter, emits a signal seeking compatibility with another device. If your mobile phone has the ability to recharge through this means, it activates the receiving coil. At that moment, electromagnetic induction begins and the transfer of electrons starts, while the electricity entering the coil of the mobile phone circulates thanks to magnetism and fills the battery with energy. This type of technology allows for less money to be invested in some basic parts that come with phones. It also has a lower environmental impact because it does not emit as many chronic substances. That's why corporations that give away cheap promotional gifts find in these devices an alternative that suits their needs. Let's analyze in more detail the operation of the induction coils. Induction coils are a crucial component in various electrical devices and systems, including wireless charging technology. Here's how induction coils work. 1. Basic principle. An induction coil, also known as a transformer or inductor, operates based on the principles of electromagnetic induction. This phenomenon occurs when a changing magnetic field induces an electric current in a nearby conductor. 2. Construction. An induction coil typically consists of a coil of wire wound around a core, often made of ferromagnetic material such as iron. The number of turns in the coil and the properties of the core affect the coil's inductance and performance. 3. Magnetic field generation. When an electric current flows through the coil, it generates a magnetic field around the coil according to Ampere's law. The strength of the magnetic field is proportional to the current flowing through the coil and inversely proportional to the distance from the coil. 4. Induction process. When a second coil, known as the secondary coil, is placed near the primary coil, the coil carrying the current, The changing magnetic field produced by the primary coil induces an electric current in the secondary coil through electromagnetic induction. This current flows in the secondary coil, even though there is no direct electrical connection between the two coils. 5. Transfer of energy. The induced current in the secondary coil can be used to transfer energy from one coil to another. In the context of wireless charging, this energy transfer occurs between the transmitter coil, located in the charging pad or base, and the receiver coil, located in the device being charged. The changing magnetic field generated by the transmitter coil induces a current in the receiver coil, which is then used to charge the device's battery. 6. Efficiency and alignment. The efficiency of energy transfer between induction coils depends on factors such as the distance between the coils, the alignment of the coils, and the design of the coils and associated electronics. Proper alignment and close proximity between the coils maximize the efficiency of energy transfer. Overall, induction coils play a crucial role in various applications, including wireless charging, power transfer, signal transmission, and electromagnetic devices. Their ability to induce electric currents through electromagnetic induction enables the wireless transmission of power and data in a wide range of devices and systems. Now, you may wonder, how many categories of wireless charging are there? It could be said that so far two stand out. The first is PMA technology, which has the ability to replenish the energy of several devices at once. Additionally, it manages to charge the devices, even if they are 10 meters apart. Those characteristics are appealing aspects, which are overshadowed by the slowness with which the devices charge. Also, its efficiency is not as good as other similar devices. PMA, Power Matters Alliance. Technology is one of the wireless charging standards alongside Qi, pronounced Qi. Here are some key aspects of PMA technology. 1. Inductive charging. Like Qi, PMA utilizes inductive charging to transfer power wirelessly from a charging pad or base to a compatible device. Inductive charging involves the use of electromagnetic fields to transfer energy between two objects, typically a charging pad and a smartphone. 2. Compatibility. Devices that support PMA technology have the necessary hardware and software to communicate with PMA-compatible charging pads. This ensures interoperability and allows users to charge their devices using any PMA-certified charging accessory. 3. Power transfer. PMA technology supports various power levels for wireless charging, typically ranging from 5 watts to 15 watts. This allows for relatively fast charging speeds compared to older wireless charging standards. 4. Flexibility. PMA technology offers flexibility in terms of device placement on the charging pad. Users can typically place their devices in any orientation on the pad, and charging will still occur. This is convenient compared to some other wireless charging standards that require precise alignment between the device and the charging pad. 5. Usage. While PMA technology has been adopted by some manufacturers and businesses, it hasn't achieved the widespread adoption seen with the Qi standard. However, it is still used in certain applications and industries, particularly in specific regions or by companies that are part of the Power Matters Alliance. 6. Integration. PMA technology has been integrated into various products, including smartphones, charging pads, and public charging stations. Some notable companies that have supported PMA technology include Starbucks, which installed PMA-compatible charging pads in its stores. Another standard is Qi, pronounced Qi. It is a wireless charging standard developed by the Wireless Power Consortium, WPC, a group of companies dedicated to establishing a global standard for wireless charging technology. Here are some key aspects of Qi technology. 1. Inductive charging. Qi technology utilizes inductive charging to transfer power wirelessly from a charging pad or base to a compatible device. This involves the use of electromagnetic fields to transfer energy between two objects, typically a charging pad and a smartphone or other electronic device. 2. Compatibility. Devices that support Qi technology have the necessary hardware and software to communicate with Qi-compatible charging pads. This ensures interoperability and allows users to charge their devices using any Qi-certified charging accessory, regardless of the brand. 3. Power transfer. Qi technology supports various power levels for wireless charging, ranging from standard power, typically 5 watts, to fast charging, up to 15 watts or more, depending on device compatibility and charger capabilities. This allows for relatively fast charging speeds compared to older wireless charging standards. 4. Efficiency. Qi chargers are designed to be efficient in terms of power transfer, minimizing energy loss during the charging process. This helps reduce heat generation and ensures that devices are charged quickly and safely. 5. Ease of use. Qi chargers offer convenience and flexibility in terms of device placement on the charging pad. Users can typically place their devices in any orientation on the pad, and charging will still occur. This is known as drop and charge functionality, making it easy for users to charge their devices without needing to fiddle with cables or connectors. 6. Integration. Qi technology has been integrated into a wide range of products, including smartphones, tablets, smartwatches, charging pads, and even furniture such as desks and nightstands. Many major smartphone manufacturers, including Apple, Samsung, and Google, offer Qi-compatible devices. 7. Global adoption. Qi has become the dominant wireless charging standard globally, with widespread adoption by manufacturers, businesses, and consumers. It is supported by over 500 companies worldwide and has been integrated into millions of devices and charging accessories. Overall, Qi technology offers a convenient, efficient, and widely compatible solution for wireless charging, making it a popular choice for users looking to simplify the charging process for their electronic devices. So, why choose wireless chargers? There are several reasons why many people and businesses have started using phones with wireless charging. One of them is that since cables are not manipulated, there is less deterioration in the physical connector. Therefore, constant replacements are not required, and the lifespan of the piece increases. Furthermore, the elimination of cables represents a comfort feature for users since they only need to place their mobile phone on the generator base or near it. This prevents people from tripping over cords or the device falling and getting damaged. On the other hand, in Europe, it is projected that by this year, wireless charging will be universal. Therefore, it is expected that all phones will have this function built in, and devices will have the capacity to replenish the energy of devices regardless of the brand. This aspect, more than a law guaranteeing user convenience, is a generous measure for the environment. This is because it reduces the production of electronic waste and opts for a more sustainable option. Although these devices generate a slightly slower electrical charge, instead of being a disadvantage, it is a benefit. Their degrading effects on batteries are greatly reduced, so that element functions better for a longer time. Hey YouTubers! If you enjoyed this video and found it helpful, don't forget to hit the subscribe button and give it a thumbs up. Your support means the world to us and helps us create more content like this. Stay tuned for more exciting videos.